Hello everybody. To understand more how the electrons are moving around the nucleus, after knowing that we have energy levels and we knew how many electrons are there in each energy level, we need to understand or we found some more observations that were very, very interesting. The information was that when we did the prism experiment on the discharge of hydrogen emissions or the hydrogen emissions, and we found that it breaks into or splits into these lines, and we found that these lines correspond to energy levels. When we took a closer look at the lines, we found that the lines are not a single line. So we found that the second energy level consists of two very, very close lines. The third consists of three very, very close lines. And this means that the energy levels are not just energy levels. They are energy levels containing some sub-energy levels. We can call them subshells. And these subshells have very close energies that they look from the first sight that they are just one line, but actually they are different lines. Very, very close in energy, but they are not the same lines. So this phenomenon was called the Stark effect, which is the very close lines that are in the same place. We found that the number of subshells is equal to the principal quantum number. So for n equals 2. I don't know if I said in the previous video or not, but in the previous video we talked about the numbers n1, 2, and 3, and we call them the principal quantum numbers, which is the number of energy level. In case I forgot to mention this in the previous video. But here we found that the number of subshells in the energy level equals to the principal quantum number. So n equals 1 has 1 subshell, n equals 2 has 2 subshells, n equals 3 has 3 subshells, 4 has 4 subshells. And we found that for the next lines, for 5, 6, and 7, they all have 4. So the maximum number of subshells is 4. We call them, we give them the letter L. We call them the azimuthal or subsidiary quantum number. Subsidiary is easier, so I'll call it subsidiary quantum numbers. So we give them numbers from 0 to 3, 0, 1, 2, 3. The first energy level has only 1, the second has 2, and the third has 3, the fourth has 4, and the fifth has 5, and so on. Has 4 as well. And you could see that we call them S, P, D, and F. So the L equals 0 corresponds to letter S, L equals 1 corresponds to P, L equals 2 corresponds to D, and L equals 3 corresponds to F. So this is S, P, D, F, the names of the subshells in the energy level. When the experiments were done in more details, we found that the electrons do not fill the subshells the way we predict or we expect. So we expect that the energy levels will be filled in this sequence: 1s, then 2s, then 2p, then 3s, 3p, 3d, and then 4s, 4p, 4d, and so on. Now this is what we would expect, that we will fill each energy level till it's totally saturated, then we'll go to the next, and then next, and then next. But what we found that the energy levels kind of get overlapped when the n gets larger. So we would see that here, that between the very first energy level and the second, there is a very big gap between them in the energies, and between the second and third is smaller, and then the third and fourth is smaller. And actually, in this region and in the following regions, we have overlapping between the energy levels. So if the energy level consists of four subshells here and 4 subshells here, they're not like this. They might get like this. Some of the energy levels here would be overlapping with the energy levels here. And this is what we see here. For n equals 1, we have only 1s. N equals 2, we have 2s and 2p. And then here, 3s, 3p. And the energy of 4s is smaller than the energy of 3d. Although the D subshell is part of the third energy level, but it has higher energy than 4s, which is part of the fourth energy level. And this is why there is overlapping between the energies of the energy levels, and that's why some subshells will get filled in an order that's not expected. So the sequence will be according to this arrows that are going down left. So it's gonna start with 1s, and then 2s, and then 2p, 3s, and 3p. Until 3p it is as expected, but before filling 3d you have to fill 4s, and then go fill 3d, 4p, 5s, and then 4d, 5p, 6s, and you'd see that 6s is followed by 4f, and then 5d, and then 6p. Okay, so you would have the overlapping getting more and more complicated, that in the 6th energy level you would have 6s, 4f, you have the f subshell of the 4th energy level, and the d subshell of the 5th energy level. Anyways, this is how the energy levels are filled with electrons, and how the subshells are filled with electrons. And this will kind of give us more understanding why the number of electrons filling the energy levels is as we mentioned before. We will get in more details as we go more, but for this at this point, just keep in mind and remember that we mentioned this before. And this is how we knew about the subshells. The experiments that were done more on the subshells, that exposing the emissions to magnetic field, or I mean the radiations from a heated element exposed to a magnetic field, that we found that the subshells are splitting into more smaller lines. So we mentioned here that this is split is actually 2 lines, and if you expose this into a strong magnetic field, this will break into smaller lines. And this is kind of mind-blowing. You can think of this, as we mentioned before, that the atom is a very small thing. It is 10 to the minus 15 of a meter, which is very extremely small. And this extremely small thing has a nucleus, and the nucleus has electrons rotating around it. It's not just that the electrons are moving in a specific energy levels, and the energy levels are spread into smaller parts, which are the subshell. The subshell itself is broken into smaller parts, and these smaller parts are called orbitals. It's very impressive. And again, you can think of this as the sun and the planets, and the planets might have what we call the moons rotating around it, and then you have rotation inside the rotation inside the rotation, and it's the same thing here. So again, the subshells have electrons with close but not equal energies, and that is due to the rotation in the 3D space. So you would find the electrons rotating in the same subshell but in different orientations in space. And we found that the number of lines, or the orbitals, is m equals 2l plus 1, and this is the third number that we have here. So we have the principal quantum number n, and then we have l, which is the subsidiary quantum number, and then we have the orbital number, which is the we call it the magnetic quantum number, because we expose it to magnetic field, so we call it the magnetic quantum number, which is 2l plus 1. So S has 1 orbital because L equals 0, P has 3 orbitals, 2 multiplied by 1 plus 1, and then D has 5, F has 7 electrons. And the observations show that the S is filled with 2 electrons, P is filled with 8 electrons, D is filled with 10 electrons, and F is filled with 14 electrons. So we have 7 corresponds to 14, 5 corresponds to 10, 3 corresponds to 6, and 1 corresponds to 2. And this means that each orbital is filled with 2. It's exactly the double. So S is filled with 2 electrons because it has 1 orbital. Each orbital of the 3 is filled with 2. Each orbital of the 5 is filled with 2, and so on. And this is how it looks like. And to for the first orbit for S, it's not a big deal because it has only one orbital, so it takes a spherical shape. But for the others, I find it very difficult to describe these. But for this, it's kind of easy to understand. It's exactly like when you get balloons and you tie them together in this shape. So you have balloons going in X direction, balloons going in Y direction, and balloons going in Z direction. And this is exactly how the electrons rotate in the the orbitals of P subshell. So one orbital, we call it PXX, and then PYY and PZZ. This is ZZ. And you see the electrons going this way, electrons going this way, and electrons going this way, as exactly the balloons are shown in this photo. Of course, it's more difficult for D and for F because you have now 7 orbitals or 5 orbitals, so it's kind of difficult to imagine. And you might think that this is all, and that we know now the all the information that we need to know about the electrons. But there is one more piece of information, which is again, it's impressive, which is what we call the electron spinning. So we said that each orbital is filled with 2 electrons, but now we would expect that these 2 electrons will have the same energies. They are orbitals in a subshell in an energy level in an atom, but actually it's not true. Each one of 2 electrons has a slight change in energy, and this is due to its spinning. So electron, as I mentioned, it's like the moon rotating around the earth, and this moon rotates around itself, so electrons rotate around themselves. So each electron rotates either clockwise or anti-clockwise, and we give them the spin quantum number, which is S. It's half or negative half, either clockwise or anti-clockwise. And each one of them has different energy, very small change in or difference in energy between these 2. And you'd see that the electrons will fill the orbitals in this way. It fills 1, and then the second, and then the third. This is the P subshell that has 3 orbitals, so it fills each one of them. And once they are all filled, it starts to fill the energy level with the second electron. So it's kind of having a smaller energy state. So it's more stable state. That the P is each one of them is filled with 1 electron before going to fill the second electron in each one of these orbitals. Again, for the D, if you have them filled, they're gonna be filled like this, and then it starts to fill the second electron in the first orbital, the second, third, fourth, and fifth, till it's all saturated. So this is what we call the numbers that we have. And then there is a great scientist. His name was Wolfgang Pauli. He put his exclusion principle, and this is a very nice principle actually. And it states that if you have 2 electrons in one atom, then no 2 electrons, whatever these 2 electrons are, no 2 electrons can have the same 4 quantum numbers. So you would have the principal quantum number n, so it states which energy level the electron is in, and then the subsidiary quantum number, which mentions which subshell the electron is in, and then you have the magnetic quantum number, which tells you which orbital is in, and then you have the spin quantum number, which describes the spin direction. You can think of this like you're going to visit a friend, and this is his address. So the principal quantum number is the street, the azimuthal quantum number or the subsidiary quantum number is the building, and the magnetic quantum number is the floor, and the spin quantum number is the apartment. So no 2 apartments will have the 4 numbers. You would go to a specific street for a specific building, a specific floor, and a specific apartment. And the electrons are the same. This electron in this place have the 4 numbers. No other electron in the same atom can have the 4 numbers. In the next video, we're going to talk about some more kind of theories that were put on about the electrons and related things. And I'll see you then, inshallah. Goodbye.